Hello, fellow investors and friends of Delta Resources. This is Tessier, your president and CEO. Today, Delta released its final results from its first drill program at the Delta 1 property west of Thunder Bay in Ontario. With this president's message, we hope to better explain these results and why our team thinks they are so significant. The complete video is less than 10 minutes, and I hope you enjoy. Before we get started, please read through our forward-looking statement when you get a chance, as some of the statements contained in this presentation fall under forward-looking information within the meaning of Canadian securities laws. I also need to tell you that as a professional geologist and a professional engineer in the province of Ontario, I am a qualified person under the rules of National Instrument 43101. For those who haven't followed us, shame on you. Well, at least this video is going to give you a chance to catch up. The project is located 50 kilometers west of the town of Thunder Bay, Ontario in Canada. The property straddles the Trans-Canada Highway, so access and infrastructure are terrific. It's a large property, now covering over 45 square kilometers. Geologically, the property is located in the Shibandawon Greenstone Belt. For all intents and purposes, a greenstone belt very similar to the better-known Abitibi and Wawa belts to the northeast, but much smaller. The property covers a 17-kilometer strike extent of the Shibandawon structure, located right here. This break, in turn, would be geologically equivalent to the Cadillac break in Abitibi, although nowhere as well known or historically as prolific. That said, the Shibandawon Belt does host gold deposits, such as the Moss Lake gold deposit right here, located in the Shibandawon structure and hosting nearly 3 million ounces of gold in the indicated and inferred category. The Moss Lake deposit is a low-grade bulk tonnage type deposit. If we zoom into the property, the geology appears to be very simple, with mafic volcanics in green, cut by ultramafic sills in blue, and granitoid intrusions in the pink. These units are overlain by what are called Temiskaming type sediments in yellow. These types of sediments are deposited in structural basins along very large structures, such as the Shibandawon structure right here, and the Saganaga structure right here. We'll see later that the geology gets a lot more complex as we zoom into our drill program. Although this was Delta's first drill program at the property, there had been exploration in the past. The red stars show gold occurrences encountered in the past, but this one right here, the Eureka, was the one of interest to us. That new discovery had never been drilled over a strike length of over 1.5 kilometers. That's until our drill program. Zooming in on the Eureka occurrence here, this is what we see. The map to the right shows the surface trenches that led to the discovery, these hashed marks right here. The photo to the left show how altered and oxidized the rocks are. In fact, it's extremely difficult to map the rocks at surface because they're virtually unrecognizable. We drilled 6 holes in 3 sections to see if the gold mineralization continued at depth. We drilled 3 sections spaced by 100 meters, a western section right here, an eastern section, and a central section. And this is what we intersected for lithologies. This slide shows pictures of the core to the left and the same map view seen in the last slide. From north to south, the drill holes intersected well-bedded clastic sediments in pale blue, ultramafic volcanic flows in dark green, and feldspar-furic basaltic to andesitic flows in pale green. The rocks are also cross-cut by feldspar-furic intermediate dikes we believe are of syenitic composition. Now, this is meant to show the stratigraphy with the freshest rocks possible. This, however, is what the rocks really look like when they're altered. On the right-hand side, the drill core shows the altered lithologies. What we see here is that the mineralogy of the rocks is completely obliterated and altered due to intense silicification, anchorite, and pyrite alteration. But yet the textures of the rocks remain. This is telling us the rocks are chemically altered but not deformed. In addition to being altered, all rock types are also cross-cut by hydrothermal breccias and overprinted by gold mineralization. On the left of the screen are photos of the breccias. In fact, there's at least 2 generations of breccias, as we can see on this first drill core. We see fragments of various rock types and sizes in a black matrix of aphanitic or very fine-grained quartz. We can even see fragments of mineralized vein within those breccias. Again, the fact that we can still easily recognize these fragments show us the rocks are virtually undeformed. To the right, we show the gold mineralization that occurs as disseminated type with pyrite, but also associated with several generations and types of vein and stockwork mineralization. This tells us the mineralizing processes were active for a very long time, giving the area potential for sizable deposits. Now, these next 2 slides will show the eastern and western vertical sections. We didn't represent the central section simply because there's only one drill hole and nothing to correlate with. The map in the lower right corner of the screen shows where the section is located, and the table shows the drill hole intercepts. The sections are vertical and looking more or less towards the east, like so. What we see in section is our rock sequence with the sediments in blue, the ultramafic in dark green, and the basalts in pale green. The dikes are shown in pink. The triangles along the drill hole traces represent the hydrothermal breccias that affect all rock types. The dashed red outline shows the extent of the mineralization. You can see the near surface very wide intercepts of low-grade gold in hole 3, here with 141 meters of 0.17 grams per ton gold. Within this interval, some higher grade material was also intersected with 27.5 meters of 0.64 grams per ton gold, also near surface. There's also some material grading over 1 gram per ton gold. More of the same on the western section, with the same sequence of rocks cross-cut by dikes and hydrothermal breccias, similar near-surface wide intercepts of gold mineralization, here 137 meters of 0.2 grams per ton gold in drill hole number 5, with an intercept of higher grade of 0.73 grams per ton gold over 22 meters, and again material over 1 gram per ton gold. One important point you may have noticed from this slide and the preceding one is that gold mineralization is getting wider and appears to be getting higher grade towards the north. This is what we call the mineralizing vector, and that's where we'll likely direct our next phase of drilling. So in conclusion, the Delta 1 drilling program intersected very wide, near-surface, low-grade gold intercepts with higher grade sections over 20 meters long, grading between 0.64 grams per ton gold and 1.1 grams per ton gold. Mineralization is open to the east, the west, the north, and at depth. The gold zone appears to become wider and higher grade towards the north, vectoring us in that direction. Pervasive and intense alteration, widespread low-grade gold mineralization in undeformed rocks, and multi-phase disseminated style gold mineralization all suggest a very strong and long-lived mineralized system. The objective of future exploration will be to identify the feeder structures of the system that host higher gold grade. Permitting is underway at Delta 1 to resume exploration activity in the very near future, and that permit application includes potential for 20,000 meters of drilling program. Thanks very much for listening to this video. I hope I was able to convey how excited we are and about the potential of this property. As usual, don't hesitate to contact us should you have any questions or suggestions. Just a reminder that we'll be at PDAC from March 1st to the 3rd at the Toronto Convention Centre in Toronto, booth number 3032 on the Investor Exchange floor. Until next time, this is Tessier on behalf of the whole Delta team. Thanks very much.